Okay, so this is in response to your homework problem number 3, part D, which is asking about the compression of the ball. Sorry, this pen doesn't show up very well, so instead of just sending a picture, I thought I'd do a video. We first, earlier in the problem, did the 5 variables for the downward motion, which would be v initial of 0 meters per second. We didn't know how fast the ball was moving when it hit the ground. An acceleration of negative 9.8 meters per second squared. The negative comes from the fact that the problem asks us to treat upward as positive, and it falls a distance of negative 1.9 meters. Doing some kinematics earlier, we choose the equation without t, v squared equals v naught squared plus 2ad. We substitute in and we get that the final velocity is 6.1 meters per second pointing down, which means mathematically we should treat it as negative 6.1 meters per second. So then for the last part, when we're talking about how much does the ball get compressed, we have a new kinematics problem. Again, kinematics means a constant acceleration. So when it's in contact with the floor, the acceleration is no longer 9.8 meters per second squared. In fact, you'd really have to treat that as two separate problems because on the way down it's decelerating, compressing, and then as it uncompresses, it has an acceleration in the opposite direction. So that might have been part of the problem here. So we know v initial is negative 6.10 meters per second. We know that when it's finished compressing for that moment in time, there's 0 meters per second, but it seems difficult to figure out what to put as our third variable, knowing that you need 3 variables to solve a kinematics problem. We're looking for d. So I had a choice, given the information from the problem, to either use the acceleration or the time. In the end, I decided it was easier to look at the total contact time. It's in contact with the floor for 0.08 milliseconds, or 0.08 times 10 to the negative 3 seconds. What this means is that half of that time is compressing the ball, and the other half is uncompressing the ball. So, let's see if I can change my other slide. I took half of that time. So basically I'm saying that the ball is being compressed for 0.04 milliseconds. Now that I have my third variable, I choose an equation that doesn't have acceleration in it, which is d equals 1/2 v naught plus v times t. I substitute in and I get 1.22 times 10 to the negative 4 meters, which is the correct answer. Hope that helps. Thanks.